Hello, this is the third question of positive, negative, and zero sequence currents, fault currents, and we are given with Z bus matrices. As you are following my video, in video number 1 and video number 2, I have discussed in details how to solve line to ground faults. This is a very quick tutorial. So first of all, I will solve the part A. Here I have put the single line to ground fault formula. Fault happens at bus 2. So here we will use second row, second column, second row, second column, second row, second column. So we have found the part number A. Part B is saying we have to find the current components at bus 4 adjacent to the generator. So for that one, we know these are the formulas for voltages, and we have found del V. This already discussed in the last tutorial. Del V4, del V4, del V4. But if you see, you come to know that the reactances are not given in the question. Positive, negative, and zero sequence reactances are missing. So in order to find the currents, we have to find the reactances. So here you have to observe very carefully how you can get or calculate the reactances. For this one, this is our bus matrix for positive and negative sequence. We know that our bus admittance, I mean Y, is the inverse of Z, and by using the calculator I find these values. And if you have already solved the bus admittance, you come to know that you have to change the sign of the whole matrix inside. So the value which you get through calculator, you have to multiply the minus sign with the whole values, so you will get this value. From here, actually these are the reactances, these all are the reactances. From here you have to find the reactance of the generator. So if you see in the question, you can see that the generator is connected to bus 4. It means that Y bus 4, I mean fourth row, fourth column will be for the generator reactance. So I just put dot 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 because I don't need the other quantities, I just need this one. At bus 4 we have the generator reactance, but at bus 4 the reactance of transformer is also attached, so you have to write plus 1 over xti. So the next point is you have to find the xti because both quantities are unknown, so you have to find xti. Now in the whole matrix you have to observe in which point you can get only value of xti. I mean iota, you can simply say xt. So at 3, I mean bus 4 to 3, fourth row third column, I can get the negative reactance of transformer. All these things are detailed discussed in the Y matrix, in the chapter of Y matrix using the transformers. So I don't want to go in detail in this section. It's better if you are not understanding, then it's better you have to do the Y matrix first. So from bus 4 to bus 3 we have minus 1 over xti, minus 1 over xti. And by comparing both matrices, I come to know that this whole matrix is equal to minus 20i and this whole matrix is equal to 9.987 or minus or plus 10. This is plus. Okay, so by simply solving this one, iota iota, 1 over xgi is equal to minus 10i and xgi is equal to 1 over minus 10 iota, and it will be 0.1 iota. This is the value for positive and the negative sequence, and we also need to know the zero sequence reactance. We need a zero sequence because, as you can see in the formula here, as you can see, it's current multiplied by reactance 0, and after this one we calculated it as V40 is 0. So you can leave this zero sequence, but in some questions this is not 0. So then in that cases you have to find the reactances of zero sequence. Okay, so I will solve this one for you. So guys, here I was given the zero sequence bus. As I did it with positive and negative sequence, I do exactly same. I mean inverse of this one is the y bus. So I get this value, and by multiplying the minus sign I get all these values. So exactly same I have to see where can I get the reactance of generator. But before proceeding for the zero sequence, you have to draw the equivalent circuit. That is very important. And here I have drawn very roughly the zero sequence circuit. I have already briefed in my previous videos about the positive, negative and zero sequence networks, how to draw. So here you can see we have two transformers, T1, T and T here. All others are here grounded, here grounded, here grounded, like that. So you can see that similarly at 4 I can get generator reactance 1 over xgi 0 plus 1 over xti 0. This is 0 basically. So here I cannot take 4 3 because here it's grounded. This is a 3. I cannot take 4 3 1 over xti. This is 0 because here it's broken. I can only take transformer value from 2 2. 2 2 is 1 over xti. Here you should note that this is transformer and this is second transformer, so you can take the values and put it in the other transformer. It's not an issue in zero sequence. So by comparison you can see that this is minus 10 iota and this whole value is minus 15. By putting values you will get xg zero sequence is 0.2. Now you can put the values in your original equation, as we have known all the unknown quantities. This one we have known v4d, x4d. You can find id, ii and i0 for all three cases. I0 is already 0 because in this case v4 is 0. So here I have found calculated the values igd, this one, and igi, g means generator, this one, and ig is equal to 0. Here the next part is the phase shifting, because the transformers are involved. Transformers are involved here, so we have to do the phase shifting. Okay, here you can see our reference bus is the one that is having the fault. This one is the faulty bus. So this is the reference bus. Then it comes the bus 1, and this is the 30-degree apart, and then comes the bus 4 where we are right now calculating our generator currents, and the total from the reference to the generator bus is 60-degree apart, minus 60 degrees. So our phase shift would be minus 60 by 180 cross pi by minus sign for the positive sequence and negative negative sign for the positive sequence and positive sign for the negative sequence. Make sure your calculator must be in radian mode while calculating the values. So this I already explained: cos theta plus j sin theta. Theta, the whole value is theta, that is minus 1.047 iota. Sorry, not iota, 0.10472, minus 1.0472. Then you come, this value comes. Similarly for the negative and zero portions, this value comes. So I believe it helps. Thank you.